Hey guys, so today we're going to be talking about surface areas of prisms and cylinders from unit 10, lesson 10.6. But before we get to the notes, I wanted to give you guys kind of a visual representation of what we're going to be talking about. So here is my prism. Yes, just got done eating some cheesecake. It was absolutely delicious. It's fantastic. So here's the box. This is the prism. Now, it's going to be talking about things like surface area and lateral faces and all these things. So I just want to give you a representation of what that looks like three-dimensionally before I try to explain it on paper, if that makes sense. So on here, this side and this side, I could call my bases. And then if these are my bases on top and bottom here, the lateral meaning sides, this, and this would be my lateral faces. Okay, now I could also set the box like this. Cool. Now here and here are my bases, and my lateral sides are here, 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 and here. Okay, I could even set it like this and be the same thing. My lateral faces would be here, 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 and on the back side as well. Okay, so however you want to look at it. We're also gonna, so that's what, for a prism, and it's going to talk about a thing called a net, which if I break this all apart, hopefully I do it somewhat clean here. This would be considered the net for my prism, because if I fold this all back, I get back to the original shape. So sometimes it's easier, like we just talked about finding area of like parallelograms, trapezoids, and just recently circles and things like that. It's a lot easier to find the area if you just lay it flat, because then it's just length times width, right? But now, when it looks like this, we're going to find the area of this side, which is going to be the same as this side. And then we're going to find the area of this side, which is going to be the same as this side. And then we're going to find the area of this side, which is going to be the same as this side. And all that added together is going to be my surface area. Now, we're not just talking about prisms, we're also going to be talking about cylinders. I'm sure a lot of you guys have this at home. Been using this like crazy lately, I bet. So here on this, now I can't set this on a side and call this a base. This will never be a base. Bases on a cylinder are always on the top and on the bottom, like this. And then so the lateral surface area is going to be this. Now, something unique with cylinders, let's see if I can get this on. I got it. Now, remember, I kind of butchered this. If we want to find the lateral area of a cylinder, now it seems kind of difficult to, wait, that's a curved shape. How do I put a ruler on that and try to find that distance and all this? Well, remember, distance around here, around the edge of a circle, that's called the circumference. We just learned about that in 10.4. So that's the distance here, and then really, it's just a rectangle with the distance here being the distance around here. So if you know the circumference and you know the height, you know what this rectangle is, the dimensions of it. Good stuff. So let's take us to our notes now. All right. So solid area, surface area of a solid, just the sum of the areas of its faces, like we already talked about. A net, that's when I broke this all apart. The lateral faces, remember, are on the sides. Lateral surface area would be a lateral area of a prism would just be the sides. Lateral surface area of a cylinder would be this. So let's start with the net first. It says example 1, using a net to find surface area. So basically, if I find this area and this area and this area and this area and here, and I add them all together, guess what? I get the surface area. So 4 times 3 is 12. Well, this distance is also 3, so it's 3 by 3, which is 9. This is 3 by 4, so that's 12. And this is 4, and this is 3, so this is also 12. And this is also 12. And this is a 3 by 3, so this is 9. So if I added those all together, I would get 12 plus 9 plus 12 plus 12 plus 12 plus 9. 48 plus. I would get 66. Or I could also think of this as I add this whole rectangle plus this one and this one. I don't know. There's a lot of different ways of doing it. However you want to think of it, whatever makes sense for you. So yeah, area of a rectangular face. Remember, yeah, that's just 4 times 3, so that was 12 feet squared. And then for the other ones, it was 3 times 3, which was 9 feet squared. So when we add these all up, it was 12 plus 9 plus 12 plus 12 plus 12 plus 9, which again, as we already said, 66 feet squared. So surface area of the storage chest was 66 square in feet. All right. Surface area of a prism. Surface area equals 2 times the base plus perimeter times height. 2 times the base, so I find the area of this base and the area of this base, plus the perimeter around the outside here, times the height. Because if I have that, so that's like on here, if I find the area of this base and this base, cool, plus the perimeter, so distance around this, well, distance around that, distance around that, around this whole thing, times the height of the whole thing, that would give me the surface area. So for instance here, it says find the surface area of the prism. Well, how do you find area? Now in this case, the bases are triangles. So how do I find area of a triangle? Remember area triangle is 1/2 base times height. So in this case, the triangle is 1/2 times the base, which is 5 times 12, or 12 times 5, doesn't really matter. So plus the perimeter, which is 5 plus 12 plus 13. 5, 12, and that's 13. Right? The perimeter of the whole thing times the height, which you said was 20. And if we do all the math there, you end up getting 660. Because half of 12 is 6 times 5 is 30 plus 5 plus 12 plus 13 . 30 times 20. So 2 times 30, so 60 plus 600. Yeah, is 660. So the surface area of the prism is 660 square inches. All right. Surface area of a cylinder. 2 times the base plus the circumference times the height. So in other words, it's 2 pi r squared plus 2 pi rh. So looks really long and has a lot of things involved here, but really it's just these two things, just those two measurements. When you plug those into the formula, you'll get out your surface area. So in this case, 2 pi times now r. Now this is saying the diameter is 3. Now, if the diameter is 3, remember, what does that make the radius? Half of that. So in this case, that's going to be 1.5. 2 pi times r, which again is 1.5, times the height, which is 5. And the nice thing is you guys can just plug this all into your calculator. You go 2, in fact, so you can see it a little better. So I'm going to go 2 times pi, which is right here, times 1.5 squared. So it looks like this, 2 pi 1.5 squared plus 2 pi 1.5 in parentheses and 5 in parentheses. Remember, whenever you're plugging stuff in, it's always a good idea to use parentheses around it, what you're plugging in. And when you plug all that in, you get 61.3. So yeah, we got 19.5 times pi, yeah, which ended up being 61.3. So it's 61.3 square inches. All right. So let's go ahead and test these last ones. So find the surface area of the prism of the or cylinder, write down your answer to the nearest whole number. So remember, area of the rectangle or the prism, area equals 2 times the base plus perimeter times the height. So area equals 2 times the base, area of the base, which is going to be 13 times 5, plus perimeter, which is 13 plus 5 plus 13 plus 5 times the height, which is 6. So area equals 2 times 13 . 2 times 5 is 130 plus 26 plus 10 is 36 times 6. So area equals, and I plug that all into my calculator. Just plug it in just as it is, 130 plus 36 times 6. So it looks like that. You get 346 meters squared. Now remember on this one, surface area equals 2 pi r squared plus 2 pi rh. So surface area equals 2 times pi times radius, which in this case is 5 squared, plus 2 pi times my radius again, 5 times my height. And luckily, you can plug that all into your calculator. So it's going to look like 2 times pi 2 pi r, which in this case, again, is 5, close parenthesis, squared, plus 2 pi, parentheses, 5 again, r, times h, which is 11. Plug that all in like so. And I end up with 500 and, let's end round to the nearest whole number, so we're going to call it 503. Feet squared. And there you go. That concludes 10.5, surface area of prisms and cylinders. Let me know if you guys have any questions about that at all. Thanks.